Hello everyone, welcome to the Hangout for the course Data Science in Stratified Healthcare and Precision Medicine. And I'm Min Hong, I'm the teaching assistant for the course.
Hi, my name is Areti. I'm one of the course instructors in the MOOC.
And hello, my name is Dr Thanasis Tsanas. I'm here as an additional presenter for specific topics.
And yes, today we are very happy to have Thanasis with us. So later we will have a short interview with Thanasis to get more ideas about the projects in data science in healthcare. And then Areti will provide a recap for the course, talk about what have we seen so far and what are we going to see in the next few weeks. And then I will talk about the discussion forum I've been supervising until now, and also Areti will provide some updates about some related news. Hopefully you will find it interesting. And look at Thanasis. We are very happy to have you here and thank you for your time. And can you give us a brief introduction about yourself and talking about what is your research area?
Sure. So I come from an engineering background originally. I did my master's in computer science, my PhD in applied mathematics. For a short spell, I was in the business school and now find myself in the medical school. So I'm a Chancellor's Fellow here in the University of Edinburgh. And my work is primarily with time series analysis, signal processing, and machine learning, primarily with applications in the biomedical domain. So essentially, I'm trying to make some sense of data and trying to develop clinical decision support tools.
Yeah, so you were talking about clinical support tools or like data science in healthcare. And can you give us an example of your research, like a specific project, so we can get more sense about?
Sure. So one of my favorite topics was continuing the work I've done on my PhD, which essentially the idea is you have people with Parkinson's, and it's very difficult to remotely monitor symptom severity, so both towards diagnosis and towards following up the symptoms. Now, the classical problem is that currently there are not enough clinicians to do it properly, so ideally the patients would be seen by the experts every couple of weeks. In practice, they are seen by experts every 6 to 12 months because simply lack of resources. And that has immense implications for their health because they cannot be assessed frequently and hence they do not get the best treatment in terms of drugs and potentially surgery. So we came up with a way where basically we use voice, and on the basis of processing voice signals, we can remotely, very accurately identify the symptom severity across lots of different modalities. For example, just using sustained vowels, so someone says as long as possible. Just on the basis of that sustained vowel, you can identify the propensity for someone to fall, how they might freeze, or the extent of their tremors, and so on. And basically, the big success of this project is that we can actually do it with accuracy which is greater than the inter-rater variability, which means if you had to train the experts in the room, they might differ by more than what our algorithm does against an expert, which is really remarkable.
And talking about the data processing, what do you think is the typical process, or like for the data processing, and also like before or after we get the data, like what would you do like before you get the data and after?
Okay, so there are two parts. So the first part is what you do before the data. So it's actually very good to have a data scientist involved before data collection takes place. So you have to think about the implications, for example, the sample rate. So how frequently you're going to sample data to get meaningful quality. You have to think about the environment. So where you're collecting the data. For example, the problem mentioned before with voice, you have to do it in ideally in a very quiet room to get good quality data. So the data quality is paramount to get things on a good start and do the processing and develop something which is meaningful. In terms of and of course, try to document in a specific way, which is very minimal for processing, because that can be a big problem. And then once you have the data, then to my mind, there are basically 4 main steps. So the first step is trying to extract features from the data. So you have some data in some raw format, like voice or images or videos. You have to try to apply some algorithms that you can basically extract in some raw format that you can process further. The second step is essentially applying some algorithms, some classical statistics that I know you teach in the course, to basically make some sense of how these are associated with the clinical outcome that you're interested in. The following step is basically applying some parts of more advanced algorithms. That's part of machine learning, where basically you try to identify a subset of the features that you have, and then do what we call a statistical learning process, where basically you do the mapping with the clinical outcome. And the last crucial bit is bringing things back to the domain so that the experts can understand it.
Yeah. And yeah, you were talking about features selection, and also some advanced algorithms for machine learning, and also mapping the output for like clinical meaningful interpretations. And yeah, I would recommend to link it, like have a look for the content we have in week 3 for machine learning, and this is a typical process for a machine learning project for data science. And also one more question about like what is the most challenging thing you find during your research?
Sure. So the typical problem we have, so most of my data come from clinical colleagues, and a large part of my time is basically trying to get data in a format that is amenable for further processing. So one of the biggest challenges is getting the data in the right format so they can process it further. So this can be in terms of data quality, so it doesn't obey certain rules. Sometimes you have variable quality because different devices might have been used. Sometimes the data has not been recorded accurately. We observe this with lots of database where, for example, you might have non-physiologically viable figures coming in, for example, temperature which would not be reasonable for someone who's alive. And a big challenge there is to try to ensure that the data is conform to these principles and make sense before you actually do any analysis.
Yeah. So also the communication with their clinicians will be really important for healthcare data. And because we have quite a lot of people new to coding or new to Python in our course, and do you want to share any tips you have for the people new to this area?
Yeah, so I'm not programming Python myself, but the good thing is that all the learnings you have from different programming and different aspects can be directly transferable. So the first thing is definitely you have to live with the data. So you have to spend some time with the data set. You have to understand the intricacies and what's happening, what could be going wrong. The way I approach this, usually I may have some tools that I have used in past projects that I can think that are easily transferable in this domain. Sometimes you can use tools that other people have developed, as long as you understand them and you know what is happening. So you can apply this in MATLAB, R, Python, whichever language you prefer. And ultimately, you have to develop your own tools because that's something you understand. That's probably something that has to be tailored to solve a specific problem that you're facing.
Yeah. And also, I believe there's always a lot of resources to use online nowadays, especially for mathematicians in MATLAB. And do you have any more questions?
I do, yes. I have many questions actually, but I'll try to control myself. So going back to the research project that you described, the one with Parkinson's patients going, and then you analyzing that data. I was wondering, is the same idea and approach applicable to other diseases?
So the quick answer is in principle, yes.
Okay.
But we haven't done it yet. So some people have reported their findings with some other disorders. We believe that you can probably generalize across a range of different disorders. So one of the areas I'm working on currently is with Friedreich's ataxia.
What is that?
So Friedreich's ataxia is basically, once again, a neurodegenerative disorder, and I don't want to go into too much detail because that's not my area, and probably I'll say something wrong here. But once again, these people have debilitating symptoms, and it's going to be very interesting and practical from a clinical perspective to be able to remotely assess what's happening, both diagnosis and clinical monitoring. And some of my colleagues are actually working on Alzheimer's, so using voice to assess how things work with, for example, depression and other symptoms that you have in Alzheimer's. So yes, in principle, voice is a key modality that you can use and capitalize on to capture lots of different physiological properties that you may want to quantify.
Yeah, that's amazing. So just out of curiosity, so is this kind of research stream, has it been going on for a while, or is it more of a recent development? And what is the landscape like?
Yeah, so people have been working in the area of voice analytics for many years, at least since a lot of fun back in the 60s. But definitely the field of biomedicine, I think, has been increasingly used since around 2000 or so. So a lot of work has gone in from around the area of, I guess, 2000, 2004. That's when this field of biomedical voice analytics has taken off. And I think since 2010, perhaps over the last decade, this has really sparked a lot of interest across the globe. In part, that's because of the development of big databases that enable further processing. And of course, we have improved in terms of the algorithms, we have improved in terms of machine learning, we have improved a lot of areas, and that's really an exciting area to be.
That's amazing. So in the course, we do talk about unstructured data, and we talk about medical images, we talk about text, but actually we've never touched on voice. So that's something that we could explore in the future. I do have another question. That's going to be the last one. So when Minpeng asked you about the data science process and the challenges, and you focused on the data collection, you mentioned documenting data. So I was hoping you could tell us a little bit more about that, because this is not something that we really discuss in the course.
So frequently when colleagues collect some data, it's a good, I guess, part of the process if you can have a dictionary. So part of the problem is that frequently you get some modalities, for example, temperature, and you haven't recorded the units. And we have had a problem a couple of years ago, so it was back in 2012, we were working on the NIMI database, which is on the public big databases. And we were processing some data from the intensive care unit. And this is basically data that is collected in Boston. And there were a lot of European nurses, and part of the problem was that some of them have recorded the temperature in terms of Fahrenheit, and some of them in terms of Celsius. Now that is a fairly easy problem to actually overcome with some signal processing, which is not too sophisticated. So in that case, that was something that we can address, and if you will, almost reverse engineer and bring the data in the form that we want. But in other cases, it's very difficult to understand what happens, and then the person who's responsible for collecting the data has left the project. And then it becomes quite tricky, because the PI perhaps is not exactly aware of this specific variable. So I think it's quite key that when you collect the data, you document properly what happened, you have full ideas about, for example, this specific individual. There are lots of things that you cannot control for, you cannot have all this information in the world that perhaps you might let think of. But it's very good to have a good thing about in the beginning of the study.
Yes, I think this is really important. And in fact, what I've seen with research projects is that very often we don't think as long-term as we could or should. So we make assumptions about who's going to be using the data set and how we put together that data dictionary. And anyway, without that kind of documentation, it will not be usable in the future. So thanks for pointing out. I think that's all the questions I had.
Actually, we got one question from our audience. Can we have a look? Just take one more minute. Somebody says, Aaron says, I wonder, has there ever been any analysis on handwriting with regards to Parkinson's disease patients using machine learning? I think we've talked about it before, right?
Yes, so the answer is yes. There is a battery of tests you can use for assessing Parkinson's disease. Some people have actually focused, as you suggest, on handwriting. One example is, for example, the spiral. So people are asked to draw successive circles, and you can imagine for someone who's healthy, they can do it almost fairly accurately. For the circles, some Parkinson's would have problem doing it. Some of my colleagues are working in that exact area, and that seems to be quite predictive as well. So my feeling for Parkinson's, for other disorders, is that we'll have to be capitalizing on lots of different modalities. Voice is one of them, handwriting is another one. Having a wearable device and monitoring, for example, how someone is walking or how someone is moving or they sleep, circadian variability, and so on. So there are lots of modalities that ideally can provide a more coherent picture of someone's progression. So yes, I think that it's actually very useful to be collecting all these different data sets and different modalities.
Yeah, and thanks to Aaron for the question. And Aaron, would you like to talk about the course and a short recap?
Yes, yeah, absolutely. So the course has been running for almost 2 years now, and we cover lots of different topics, so different ways of working with data and analyzing data. So just linking with the things that we just discussed, so machine learning, for instance, is one of the topics in the course, and we discuss this in week 3, as we do cover probabilistic modeling as well, and I believe that's something that you've been working in. Then when it comes to non-standard data or unstructured data, on week 2, we look at medical images, and on week 4 of the course, we look at text, so natural language processing. There's a little bit of programming in the course, and typically we use structured data there, so you can think of a table with rows and columns. But on week 5, which is the last week of the course, we talk about a different paradigm, a different way of representing data, which is graph data. And I think that's quite interesting. I'm not going to expand any further, but I think our learners might be at different stages right now following the course. So any questions you might have about these topics, or if you would like to have a hangout on a particular topic that we cover in the course, do let us know, and we'll make it happen.
Yeah. And also, I want to talk about the discussion forum that I've been supervising, and we got quite a lot of questions about detailed coding problems, and I believe it's solved, so I'm not going to repeat it here. And just want to mention that we have a list of the resources on discussion forum for the beginners for Python, especially for Python, and it's on the general discussion section, and we will ping it for in the future, so it's easier to find it. And also, we have an instruction of how to use Jupyter Notebook in week 1 reading materials, because we have quite a lot of questions about specifically about Jupyter Notebook. So it's a good resource to get a sense of running the code on Jupyter Notebook. And also, I just want to suggest that it's good for you to run the code step by step if you are new to Python, and to understand each command one by one. And because we got some questions about the code doesn't work in our example codes or whatever, and high probabilities about we miss the formal code for loading the libraries or assign the value to some specific variables. So it might cause some errors in some codes running. So it's better to run it step by step. And also we got many questions about asking for assignments, peer reviewing, and I just want to encourage people to, it's compulsory for you to do at least 2 peer reviews, right? And if you have time, or if you are happy to do it, and you can do more than 2 peer reviews, and it's a good way to see other people's ideas regarding the similar problems, and then from other people's essays or whatever. And also, yeah, and I can see there are some questions here, and I'm not sure we have enough time to go through the questions, but we are always happy to see people discuss see you in discussion forums, and we can talk about it in more details on discussion forum. And also, Arati, would you like to update some news in healthcare recently?
Yeah, I'll do that. And if we find that we have a bit of time left, then maybe we can discuss some of the questions now. So I think I'm going to focus on some events that are taking place in Edinburgh fairly soon, which are around health data science. So the first one is a really, really exciting one. It's a health hackathon, basically. So it's called Digital Health Product Forge, and it's taking place from tonight till this Sunday, taking place in Edinburgh. There are still tickets left, so there's still time to register. Let me tell you a little bit about it. So it's meant to be one of the biggest, actually the biggest hackathon in health in Europe. And the idea is to get lots of people together, people from different backgrounds and with different skills and talents. So it could be data scientists, it could be entrepreneurs, it could be designers, it could be academics, clinicians, anyone really that is interested in healthcare and making a difference, having an impact in this sector, is invited to contribute. And the idea is that cross-disciplinary teams are going to be formed, and then real-world challenges and problems are going to be given to the different teams depending on their interests. People are going to be working with data and try to address those questions. I've been there, I was there last year mentoring, and I'm mentoring this year, and I'm a big supporter. I think it's a really great idea. The way it's run is really, really good. It's a relaxed atmosphere, very open-minded, very playful and creative. When I talked to people in the past who were thinking about joining, attending, and they weren't sure, their concerns were about their background. Some of them pointed out, well, I'm not a data scientist. I don't know much about computer science. What am I going to be doing there? And in fact, people like you are needed because you can provide insights across complementary areas. So that's the whole point of getting people with different backgrounds together. It's a lot of fun. It's quite tiring, but a lot of fun and very creative. So we're going to post a message in the forums with the registration link, and keep you posted.
Yeah, I just jumping to say, because I was there last year,
very
and
good.
I really find it very interesting experience. And we were in a group for 5 people, and we have quite different backgrounds.
Yes.
Like some in data science, in modeling, and we also have people specified in user interface designing.
Yes.
So it's quite a good mix, and we have people, more senior people, and also master students. So we always can discuss together, and it's also a good way to make some new friends.
Yes, absolutely. You're right. Yeah. Perhaps worth pointing out the different kind of topics that are going to be that the focus is on this year. So the theme is integrated care and data-driven innovation, and I think the data sets and problems that are going to be put there for the different teams are around sports and mental health, social care, emergency and unscheduled care, healthcare for the homeless, and cybersecurity in healthcare. So a real breadth of problems. I think it's really exciting. We're going to put a message up there, and hopefully some of you can attend. Now, I understand this event is taking place very soon.
Yes.
The next one that I'm going to be presenting, you have a little bit more time to think about it and register. And the next event is part of DataFest.
Mm-hmm.
So DataFest is a festival of data that is taking place in Scotland. It's organized by the Data Lab, and it's been running for a few years. And there are different streams. So there's something called the DataSummit, which is a 2-day international conference with important and very knowledgeable speakers describing their experiences. There's Data Talent, which is a collider event for people that want to get involved in this area and perhaps are exploring their career options. And then there are fringe events across Scotland. So fringe events are offered and organized by different organizations, and we are offering a fringe event as well. It's called a hands-on introduction to data science in health. It's taking place on the 12th of March, around 1 to 4 p.m. In the centre of Edinburgh. It's free to attend, and the idea is to bring together people working in the health sector. So not just academics, not just NHS people, but people working in the wider area, so people in the third sector, in industry, and explore different themes in data science for healthcare. We're going to be reusing some of the resources and the materials we have in this course, and exploring different themes with our participants. So we ran an event like this last year, and it was a lot of fun. We thought the contributions from the participants were really, really good when exploring different challenges and opportunities brought by data science in health. So we thought, well, we'd better do it again. So if you're interested, we're going to post the link on the course discussion forums, and well, hope to see you there.
Yeah.
And that's everything, I think, for now. Yeah,
Okay.
we're already approaching 11 a.m. UK time.
Yeah. Okay. And yeah, so maybe we will discuss more on discussion forum regarding the questions. And also, thank you again for Thanasis. And yeah, thank you everybody. Hope
Thanks
you
for
find
watching.
it useful. See ya.
Bye.
Bye.